Okay, guys, so what we're going to do here is work on rational and irrational numbers. What we're looking at here is our template for classifying rational and irrational numbers. The bottom line is that all rational and irrational numbers are real numbers. So this is where we're going to get into the vocabulary terms subset and set. Okay, so if real numbers is all rational and irrational numbers, then rational and irrational are a subset of real numbers. Okay. When we get to irrational numbers, we'll start there. That's the easiest one. The definition of an irrational number is a number that either does not repeat or is non-terminating. So the best example of a number like that would be pi, of course, because pi does not stop. It goes on forever. That's one of the key characteristics of pi. And then it does not repeat. So it is non-terminating. And it does not repeat. If both of those things occur, then it is an irrational number. Now, going over to rational numbers, as you can see, there's a lot more subsets underneath rational numbers. So again, rational and irrational numbers are real numbers. Rational and irrational numbers are a subset of real numbers. Irrational does not have a subset. It's just either this is an irrational number, or it is a rational number. Now, once you get into rational numbers, there are three subsets underneath that. So a rational number could be a decimal that does terminate. It could be a decimal that does repeat. So it could be something like maybe 3.3 repeating. It could be a number that a decimal that terminates, like 2.45. Now, once we get rid of the decimals, we go into integers. Integers are all negative and positive numbers, including zeros. And yes, they are a subset of rational numbers. They would not be a subset of irrational numbers. And yes, they would be a subset of real numbers. So as we go down, these areas are subsets of the one above them, or the one that's on the outside of it. So an example of an integer would be -2, -1, 0, and then all the positive numbers. All the positive numbers to infinity, all the negative numbers to negative infinity. Integers are not decimals. They are basically 0, positive numbers, and their opposites, all their negatives. Those are integers. So once again, integers would be a subset of real numbers and rational numbers. So now whole numbers. Whole numbers are a subset of integers. Whole numbers are all the positive numbers, including 0. So they would be 0, 1, 2, 3. So would a whole number be an integer? Absolutely. Would a whole number be a natural number? No, it would not, because a natural number is all the positive numbers without 0. So they would be this, okay? So a natural number is a whole number, okay, because whole numbers are 0, 1, 2, 3, and natural numbers are 1, 2, 3. So natural numbers are a subset of whole numbers. All right, but whole numbers are not a subset of natural numbers, and it gets kind of confusing, and that's why these problems are difficult on the STAAR test. So to go over this one more time. Rational and irrational numbers are a subset of real numbers. Matter of fact, everything below real numbers is a subset of real numbers. Once we get to irrational numbers, there are no subsets. It's either irrational or it's not. If it is not irrational, that means it's rational. Now, of course, rational, again, is a subset of real numbers, but it has many subsets underneath them. So integers would be a subset of rational numbers and of real numbers. Whole numbers would be a subset of integers, rational numbers, and real numbers. Natural numbers would be a subset of whole numbers, integers, rationals, and real numbers. And that's basically how we classify them. So again, natural numbers are 1, 2, 3. All positive numbers to positive infinity. Whole numbers are 0 and 1, 2, 3. All numbers to positive infinity. Integers are negative infinity to 0, and then 0 to positive infinity. And then rational numbers are all of these, of course. All the natural numbers, the whole numbers, the integers, and then now we throw in decimals, and as long as they terminate or they repeat, then it's a rational number. If they do not terminate and they do not repeat, that would be an example of a number like pi. That would be an irrational number. Okay? So now we're going to move on to what to do with irrational numbers. So in my class and in the STAAR test, you're going to be given an irrational number, and they could ask one of three things. Actually, they could ask four. So let's say they give you a square root like 42. The first question they could ask is they could say, what two whole numbers does the square root of 42 fall between? So this year, 8th grade, they're now able to use a calculator. So of course, everybody would go to their calculator and find out what the square root of 42 is, and it is 6.48. Okay? I'll put the next two digits in there, 6.4807. All right. So they could ask again, what two whole numbers does it fall between? Well, obviously 6.4 is going to fall between 6 and 7. That's what I call betweenness. Again, you need to be able to tell me what square root of 42 falls between. Once you find the square root of 42, it's 6.48. So what two whole numbers does 6.48 fall between 6 and 7? The next thing you need to be able to tell is what whole number is it closest to. Well, 6.5 is going to be the cutoff point. So if you're above 6.5, it would be closer to 7. If it's below 6.5, you'd be closer to 6. So it's closest to 6. The third thing you need to be able to do is to round. So let's say in this case they wanted you to round to the hundredths place. Obviously the 8 is in the hundredths place, so we go to the number in front of it, it's a 0. The 0 will not round up to 8, so it would be 6.48 if we were rounding to the hundredths place. Of course, if it was the tenths place, the 8 would round up to 4, so it would be 6.5. If they were going to the thousandths place, the 7 would round up to 0, so it would be 6.481. So again, you need to be able to tell betweenness, the whole number it's closest to, and round to whatever decimal place they want you to. The last thing they would ask you to do is to find the missing side of a square. And you might say, well, how does that correlate with this problem right here? It's very simple. This problem is the exact same thing as this problem. In other words, what's the square root of 42? What number multiplied by itself equals 42? Comes from a square that has the area of 42, and they're asking what number multiplied by itself equals 42. How do you find the area of a square? You multiply it, you square the sides, this side times that side. So right here we're asking for what number multiplied by itself equals 42, and over here we're asking what number multiplied by itself equals 42. So we found out that the side would be what? When we found the square root of 42, it was 6.48. Now, one of the popular things that we'll see on the STAAR test is instead of just asking, hey, here's a square with the area of 42, what's the side? They'll ask for the perimeter. And then, of course, you would need to multiply this by 4, and it would be somewhere around 24 to 26. I can say that times 4 is, if I just do 6.48 times 4, it comes out to 25.92. So the perimeter would be 25.92. And you need to be prepared to be able to do that. You need to be able to find the square root of 42 to find the side, and then multiply it by 4 so you can find the perimeter of it. And sometimes they'll say, you know, if this was a track, what would the distance be if you went 4 times around it? So then you'd have to find the perimeter and multiply by 4. Those are the kind of questions they're going to throw at you guys, and you should expect stuff like that because this is an easy concept, and so they're definitely going to try to make the easy concepts hard. So that's classifying rational and irrational numbers, discussing all the subsets, natural numbers to whole numbers to integers to rational numbers, along with irrational numbers, all under the set real numbers. And then finding the square root of a number and being able to tell what two whole numbers it falls between, which one it's closest to, being able to round it as a decimal to whatever decimal place they want, and instead of doing the traditional square root problem, going back to what it came from, which is actually, here's a square, here's the area, find the side. And that is rational and irrational numbers.